Hi, welcome back. In this video, I will discuss A-star search algorithm in artificial intelligence with a solved example. A-star search algorithm was implemented in 1968. We use the following equation to select the successor node. In other algorithms, what we do is we will select a particular successor based on the minimum cost. We don't consider the future information, we just consider the immediate cost. Based on that, we will select the successor node. For example, let us say that we are present in a particular state and that particular state has 3 successors. Between these 3 successors, we will select one successor based on the distance between the current node and those successors. But in A-star search algorithm, we use this particular equation which contains 2 components, that is g of n and h of n. G of n is the distance between the initial node and the node n, and h of n is the heuristic value, that is nothing but the estimated value from n node till the goal node. So that is the 2 information what we use so that we can select the successor node in this case. So for each successors, we will calculate this particular value. Based on this particular value, we select the successor node, and then we proceed in this direction so that we can reach the, the goal node in this case. To understand this particular methodology, I will take a very simple example. Let us say that this is the graph given to us, where S is the source node and G is the goal node. A, B, C, D, E, F are the intermediate nodes in this case. The distance between S and A is 3. Similarly, the distance between S and D is 4. These are all the distance between these nodes here. 11.5 is the heuristic value of S. The meaning of this one is the distance, or you can say that the S probable distance from S to G is 11.5. Similarly, we have 5.8 on the top of B. The meaning of this one is the probable distance from B to G is 5.8, and so on. So for every node we have a heuristic value, as well as between a pair of nodes we have a distance here. Using this thing, we have to find the path which will give us the minimum cost here, starting from S to G here. So I will start at S. S has 2 possible paths. Either I can go to A or I can go to D. So we will find the value of A, that is f of A is equivalent to g of A plus h of A. G of A is nothing but the cost it takes from S to A. What is the cost from S to A? That is 3. And g of A, that is nothing but what? The heuristic h of A. H of A is nothing but what? 10.1 in this case. That is nothing but 3 plus 10.1, which is equivalent to 13.1 here. On the other side, f of D is equivalent to g of D plus h of D. G of D is nothing but the distance, that is 4, plus h of D. How much is the heuristic value of D? That is 9.2. So if I add these two things, I will get 13.2. Between these two, 13.1 is the minimum, so I will select A here. So what we did here is, rather than just considering the immediate cost, we have considered the heuristic value, that is the distance or the estimated distance from D to the goal node. If I consider these two things, what we can do is we can make a better decisions here. So once I select A, we have to select the neighbors here. S is already selected, so 2 neighbors are there, B and D. For this particular B, we have to calculate f of B. Similarly, we have to calculate f of D. So f of B is nothing but g of B plus h of B. G of B is the distance from source node to the bth node. That is nothing but 3 plus 4. And h of B is nothing but 5.8. That is the heuristic value. So if I add all these 3, I will get 12.8 here. Similarly, for this particular D. So if I want to go to this particular D, the distance is 3 plus 5, because A is the current node here. So 3 plus 5, that is 8, plus the heuristic value, that is 9.2, I will get 17.2 in this case. Now if I consider these three, 12.8, 17.2 and 13.2, 12.8 is the minimum here. So I will consider B as the current node. I will start processing here. The successors of B are C and E. If I want to reach this particular C, the total cost is 3 plus 4 plus 4 and its heuristic value is 3.4. So the total value in this case is 14.4 here. Similarly, if I want to reach E, 3 plus 4 plus 5, that is nothing but 12 plus 7.1, that is nothing but 19.1 here. Now if I see these particular heuristic values, 14.4, 19.1 for E, 17.2 for D, 13.2 for this D. If I see all these values, the minimum value is with respect to this node. So I will start with this particular D and then I will start processing here. This D is reached how? It has been reached from S to D here. So S to D distance is 4. The neighbors of D are, there is only one neighbor, that is E. So I will select that particular, actually two neighbors are there, not E. A and E are the two neighbors. So for A, 4 plus 5 plus 10.1, that is nothing but 19.1. For E, 4 plus 2 plus heuristic value of E, that is 7.1. The answer is 13.1. So 19.1, 13.1, 17.2, 19.1, 14.4. From this particular leaf nodes, this 13.1 is the minimum here. So I will expand this particular E. There are two successors are there, B and F. If I see this particular B, if I want to reach this particular B, 4 plus 2 plus 5 plus its heuristic value, that is nothing but 16.8. If I want to reach this particular F, 4 plus 2 plus 4 plus its heuristic value, that is nothing but 3.5. So the total answer is 13.5 here. Now if I consider all the leaf nodes again, this 13.5 is the minimum here. So I will consider this particular node and its successor is G here. Now if I because G is a goal node, I will stop here. So the path to reach G from S is S to D, D to E, E to F and F to G here. So this is how what we can do is we can apply A star search algorithm to the given problem so that we can go from source node, or you can say that the initial node, to the goal node in this case. So in this video I have discussed what is A star search algorithm, how can we apply A star search algorithm to a given problem so that we can go from initial state to goal state. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.